Hello there, and welcome to the new episode in the Rise of the PyWomen series. So today we will continue to do our house price prediction case study. So as I promised, we will today input our missing values, and after that we will see that we don't have any missing values, and we will do the prediction of our model, and we will use linear regression today and random forest and gradient boosting, and we will see which of these three regression models are the best for this case study. So let's go and input our missing values. So first what we will do here, so we will input our missing values. As we can see from the previous places, like here we can see that before this, just to find it, please, like we can see here that 90% of our, so that ratio, that pool QNC has missing value ratio 99%. Then we can see that also we have miss feature as a 96%. We have LE with 93, then fence with 80%, fireplace with 47, lot frontage with 17, and then these are 1 or 50 and less. So we will read off of the missing values all of this. So let's go and do that. So we will input our missing values. So we will say like for train, so train pool Q and C, okay, C not X. Then we will say equals train, so lower cases, so train. Then the same bracket, so we will do the same, so it will be pool Q and C, and then we will say dot fill NA, and then we will say none. So we will fill by none. So there is a fill by none. None, okay. So train pool QC equals train, and we will run it. Then we will do the same for miss feature, LE, fence, and fireplace QU. So it's around 50% missing value attributes. So we will do the same. So we will copy this, and I will paste it here. So paste it here. I need 1, 2, 3, 4. So okay, then okay, and one more. Okay, so now here I will change, so miss feature, as you can see in the previous, so miss C feature, okay, and then here, so miss feature. Then the second one is LE, so LE, 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 okay, LE, no, so here is like fence, as you can see from that previous that I show you. So fence, and then we have fireplace QU, so fireplace fire, so it's lowercase b, so fireplace QU, and we have here fireplace QU, so train fireplace fill in none, okay, and run it. Then we will group by neighborhood and fill in missing value by the median lot frontage of all the neighborhood. So we will say train lot frontage equals train dot group by neighborhood, so input. Then we'll say here again want to use double brackets. We'll say lots front edge, so lot front edge, and then we'll say transform bracket lambda x dot fill na in the bracket x dot median. Okay, that will be it. I think so. Let me see. It's fine. And then we will also replace garage type, garage finish, garage queue, and garage count with none. After that, we will replace with 0 garage yearly built, garage area, and garage cars. And after that, we will also replace like basement fin type 2, basement exposure, basement fin type 1, basement count, basement QL with none, and then we will use mass vineyard area with 0 and mass vineyard type replace with none. So I will copy and paste all of this that I mentioned because it's the same that you will do here. In order just to show you after that like how you will prepare your data for machine learning prediction. So let's go and copy all of them. So we will copy carriage type. So here, so we will have so carriage type. So okay, then we will copy, as I said, so garage yearly built, so it's the same as there, so we will copy also that, then we will run it. Then the next type, so the next is like basement fin type, so I will copy and paste that also. Okay, so copy and paste, and I will run it. Then we have the next is, as I said, is trained for the mass vineyard area, so I will do that also here. Okay, and I will run it. So train. Then the next one will be train is mass vineyard type. I'll copy and paste also that. And then we have so I will put for electrical, so I'll run that also. Then we will there is no need for a value utility, so we will drop that from it, so we will add here also, so drop it. And then we want to check is there any null value or not, so we will say plt dot figure, then fig size equals 10 and 5, and then we will say SNS dot heat map train dot is null, and then we will run it. Then we will see if we don't have any missing values. So there is a missing value. Let me see. So we have utilities, we have electrical, we have machine type, area, before that basement type. Okay, then we need okay, so garage type. So we forgot garage type. We have garage type, we have garage finish garage type 2 times, as I can see now. So we don't need this, so we have to do this. Okay, copy, and then I will get rid of this line. So my mistake, past it. So we have to run this line. So garage build, then before the garage type, so lot frontage, that's okay. Fireplace, and now it should be fine. Well done. So now we don't have missing values, so everything is fine. So now there's no any missing values. It's really good. So I'm doing everything live, so live coding, it sometimes you have mistakes, but you can see that you didn't do something well. So we will now encode strings to integer, so we will prepare our data for prediction. So I will also like copy and paste all of them, because you have a lot of them that you have to encode. Encoding, it does mean because your model wants see strings, and you cannot do prediction without this. So every time when you have strings, you will encode to the integer. So bear in mind that when you're doing this, check every of the name of the column, because when I was doing this first time, I had a problem with it, because I misspelled some of them, and it was like my head was like puffing from it. So keep in mind with that. So we did that, and then we will say from sklearn dot preprocessing import label encoder. Okay, and then we will say for C and calls label equals label encoder. Okay, and then we will say label dot fit list, then train, and we will say we'll add for the C value, so train the C value dot values, so for all of the values, and then we will say train C, so for the columns, equals label dot transform list train C, and then dot values. That should be okay. Again, values, so transform, so not transform, it's transform, so C here. Okay, so we added the label encoder, so now we'll prepare data for prediction. And you can see that everything that we'll do now, it's like similar in every of when you're doing every kind of algorithm. So I have a pre-made data preprocessing template before I'm doing any of the algorithms. So like you always have to take target variable into y, and then you have after that to do a bunch of stuff. So I will explain every part of it. So first of all, we need to take the target variable into y. So I will say y equals train, and then we will add sales price here, sales, so sale price, okay. Then we will say after that we want to delay the sale price, so we will delay the sale price, and we will say delete train sell price. Here you have to have big S case price. So delete train. So first of all, okay, then delete train sell price. Sell price. Here we need P, not that P, that's P. Okay, that would be fine. So we delete it. Now we will take their values in X and Y. So we will have our X value. So our X value will be X equals train dot values, and we will have Y equals Y dot values. Okay, and then we will run it. Then we have, like, we'll split data into train and test formats. Keep in mind that you can choose the test size. You can choose whatever you want. Like on average, people will do subjectively. So today I will have my test size will be 20%. Occasionally you will do by 20%, but sometimes you can have it like 10%. It really depends on the data set and like your knowledge of machine learning. So let's go and split data into train and test format. So we'll say from sklearn dot model, then selection, import train test split, train test splits, okay, and then we will say x train, then x test, then y train, then y test, and we will say equals train test split in the brackets x y, and then as I mentioned, test size will be 20%, so it will be test size equals 0.2, then comma random state. This is like you can add a different number. I just thought it would be good to add 7. You can add another number, and like just keep in mind that you will have every algorithm, you will have x train, x test, y train, and y test. So sorry, so here test size, so okay, fine. Okay, so now we will use a linear regression. So we will first we will like train the test model. So we'll train the model, then we will fit the model, and then we will do the prediction. So we will see the predicted result and the real result. So let's first train the model. So we will say from sklearn import linear model. So linear, because we are now using linear regression, so we will import linear model. And also for every algorithm is the same, but here you won't have linear model, you have probably like maybe random forest, or like maybe I don't know CV machines, so or like decision trees. So we will say now model equals linear, so linear model dot linear regression, and then brackets, okay, and then run it. Okay, then we will fit the model. So we will say model dot fit x train, and then of course y train. Okay, so then run it. Okay, it's good, and then we will do the prediction. So we'll say print in the bracket, so let's say print, so predict value plus standard deviation, so string, so let's, and then model dot predict in the bracket x test equals in the bracket 142, and then we want to say print the real value because we want to see how we did it, is it good or not. Yeah, so we will do that. So print the real value, and then also class for the like y test, and then we will say 142, and then we can run it. So predict got an exact kilogram x test. So let me see. What if it x-ray and x-res predict value, model predict x test, x, so print predict value plus string model dot predict x text, no equal, so here we don't need that, sorry. Print real value plus string epsilon test. So let me see what the issue here. So entire using a array shape if that has a single feature or array shape if contains a single sample. So let me see. So our predict value is 1162, and you can see the real value is 1176.7. So you can see that our predict value is really good. So we did it right. So then we will do the same one. So we will do the same one with a random forest and regression, and before that we want to see the score accuracy. So we will do this. So we will run this. So we will say print accuracy for the model score x test and y test, and then we will see that the accuracy is 89%, so it's a really good accuracy. Keep in mind that everything that is over 82 is a really good accuracy. And so we will do the same for the random forest. So we will say from SQL learn ensemble import random forest regressor, okay, and then we will say model equals random forest regressor, then we will say n low bracket, so estimators equals 1000. Okay, so we did like that estimators are 1000. You can add other numbers, so it's just my estimation. So from sklearn ensemble import random forest regressor model random forest regressor ensemble, okay. And then the next step, so we will fit the model. So we will say model dot fit, so it's the same in the previous section, so x train comma white train, sorry it's small lowercase, so okay, that will be fine. And okay, and then we have to do the same thing that we did in this other, so we'll do here because we cannot print the predict value for it, so we can say here like print accuracy, so model score test, so we can do this same, copy here, paste, and then for random forest it's a bit like slower, so we will get accuracy in a bit. So after that I will do the gradient boosting also, and we will then get the accuracy for this random forest. Yeah, so let's like go and train the model. So we will say from sklearn dot ensemble import gradients. So you can see now that we have got the score for random forest, so it's 89, so it's the same, it's a better score from for the linear regression. You can see 26 and he's 41, almost 90%. And then we will do for the gradient, so import gradients boosting regressor. Okay, then we'll gbr equals gradient boosting regressor, and then in the brackets estimator, so estimators equals 100, and then we'll say max depth equals 4. Okay, that will be fine. And then of course now we will fit our method, so we will say gbr dot fit, and of course it's xtrain and ytrain. Okay, fit the model. Okay, and then okay, it's fine. And then we will print the accuracy for GBR score. So we will say it's a slightly different from the previous. So we will say accuracy GBR. Then we will say GBR dot score in the bracket x test y test, and then okay, so multiply by 100, and then we will, and that will be it. So accuracy is 91.77. So you can see that for these three algorithms, we can see that the best algorithm is gradient boosting, because we got accuracy of 91%. So to sum up, nowadays if you're doing real estate, you can use machine learning really well to predict the prices in the region where you're doing like real estate, and it will help your salesman to know how much the prices will rise in the months and in the years to come. And also you can do a little more, you can like see you can also see and test your clients, so you can help your salesman to know, depending on from which industry the person is coming, and depending is the person is in marriage or is a solo. You can also predict how much money that person will pay. So before the person is coming to maybe buy the house or rent the house or rent the office, you will know, like by dividing into the industry, you will know what's the average pricing range of the client, and that way you will like probably gain more sales for about 20% more. So that's a really really good way of doing business. So because nowadays you cannot grow your business or without like data. So please use data science wisely, and I hope you enjoyed this tutorial today. I'm so glad that we finished house price prediction. Tomorrow we will do influenza case study, so we will see if flu, when it comes to the flu, like if temperature is increasing people who have flu or not. So we all know that now in January is the season of flu, but is that really the case? So we will know what's the main reason of having a flu in January. Is it the temperature or maybe something else? We will do that tomorrow. Until tomorrow, please like it, share it, send me a feedback, and share with someone from data science world. Until tomorrow, bye.